This is the second half of Lesson 7 from Chapter 8, Making Predictions. Let's take a look at number 5 here. Based on a sample survey, a local newspaper claims 79% of the daily papers are printed on recycled paper. And if the newspaper uses 5,000 tons of paper to print its daily paper, how much of that do you predict is recycled? Well, 79%. We need to write this number right here as a fraction. So how do we write a percent as a fraction? Well, a percent is just a number over 100. So I can rewrite that 79% as 79 over 100. And now I'm going to set it equal to another fraction, and the other fraction is going to have a denominator of 5,000 tons, because that is the total amount of newspaper that's used to print the daily paper. So this is a total, so that's why it goes on the bottom. Now they're asking us to predict how much recycled paper. Well, 79% is the recycled. That's how much the local paper claims is recycled. So that number goes on top. So that's what we're trying to figure out, is our prediction of the recycled paper from those 5,000 tons. So what we're going to end up doing is cross-multiplying. Multiply that 79 times by 5,000, and we're going to set it equal to the cross product of 100 and x. So we go ahead and multiply that 79 times by 5,000, and we get 395,000. And then from there, this all equals 100x. So we can do that division. So the nice thing about this problem is dividing by 100 just cancels out two of those zeros at the end, leaving us just with the numbers that are remaining on top of the fraction. So x equals 3,950 tons of paper. So that's their prediction of how much is recycled paper out of that 5,000 tons used each day. Well, the next problem talks about Carol flipping a coin and rolling a standard number cube 40 times each. And how many times do you predict the outcome will be heads up and a prime number? Well, let's take a look at a number cube real quick. On a cube, we've got these 6 different sides, and it's a standard number cube, so we got 1 and then a 2 and then maybe like 3. And then on the back side, we'd have 4, 5, and 6. So let's take a look at the numbers 1, 2, 3, 4, 5, and 6. Now, which ones are prime? Well, 1 is not prime. The numbers that are prime are larger than 1. They have to have factors of 1 and itself only. So 2, 3, and 5. Those are the prime numbers. So the probability of a prime, and we have to find the probability of landing on heads. And so what we're going to end up doing is multiplying these two. So let's take a look at the probability of a prime is 3 out of 6 times by 1 out of 2. Well, we can reduce this fraction. It just reduces down to 1/2 times by 1/2 equals 1/4. So that's the probability of landing on a prime number and landing on a head when we flip the coin and then roll the die from these two independent events. And then from there, we want to find out, well, how many times do you think it's going to land on that if we roll and flip 40 times? So let's go ahead and set up our proportion. That's what our probability is, but we're going to set this equal to 40 on the bottom, because this represents our total. That's how many times we're going to end up rolling it over, and then we're going to have that number on the bottom, and then x is going to be the number of times that it ends up landing on heads and being a prime number. And then from there, we can go ahead and do our cross multiplying. So we have 1 times 40, so that's just 40, equals 4 times x, which is 4x. So we can go ahead and do the division there. Divide by the 4, and we're left with x equals 10. So 10 times, that would be our prediction of how many times it will end up landing on heads, and we'll roll a prime. Last problem talks about a sample of 350 video games. In a sample of this many video games, the company found 24 were defective. If the company manufactures 15,000 of those games each year, about how many do you predict will be defective. Okay, so defective, probability of defective ones. Well, our experimental probability here is 24 out of 350. It's experimental because out of a sample of 350, we found 24 were defective. Now we're going to end up setting up our proportions. So we're going to set this equal to the total number. This is 15,000 are produced each year, and we want to find out how many are going to end up being defective. And so we're going to cross multiply, so it's that 24 times by 15,000 equals 350 times by x. So go ahead and do that multiplication. This is the number I'm coming up with. 360,000 equals 350x. And then from there I just need to do my division. So divide by 350. Nice thing about that number is that we can cross off one of those zeros and then do the division from there. And when I do that division, I end up with a decimal. So here's what it is. I get a 1028.57, and then it continues on. So what we're going to do is just round this number. So we would say it's about, so here are my symbol. My symbol for about is just a set of squiggly equal signs, is about 1,029 games, is what I would say. This is about a good prediction. Again, it's not precise, but it is a good prediction because we went with our sample. As long as our sample was good, it was a random sample, and 24 games, or 24 were defective out of 350 randomly selected, then this would be a very good prediction. So those are the types of problems that you'll end up seeing on tonight's homework. Good luck.